Welcome to the tutorial screencast for the Economic Input-Output Lifecycle Assessment website. This screencast is broken up into 3 segments. This first segment will cover how to use the model and select inputs for analysis. The second segment will cover how to interpret the results as well as the options available from the results page. Finally, the third segment is an advanced tutorial on creating custom or hybrid models. So let's begin. The tool can be accessed from the home page by clicking on the Use the Tool link in the sidebar. From here, the tool page opens with 5 steps for selecting inputs. In this tutorial, we will consider the impacts associated with the production of a standard car in the U.S. We will assume that the production cost associated with this car is $20,000. The first step is to select the model year from the data that you want to analyze. Selecting this drop-down list shows data available for the years 2002, 1997, and 1992. The default is the 2002 model, the most recent data available. Models are available for the United States, as well as a few additional countries such as Canada, Germany, Spain, and China, as seen here. You may notice the option for both producer price and purchase price model. Producer price refers to a cradle-to-gate boundary, which includes the impacts associated with all processes, including resource extraction, all the way up to the assembly of the product. All processes after it leaves the production site are not included. In the purchaser price model, however, distribution of the product to the final consumer is also included. Selecting the right model depends on the processes that you are including in your analysis. In this tutorial, we will select the 2002 producer price model for the U.S. Now that you've selected a model year, we need to find the industry sector associated with the product or industry that we're attempting to analyze. In the 2002 model, the economy is divided into 428 sectors, which are grouped within broader categories. For our example, we want to find the sector that includes car production. So we click on the drop-down menu of the sector group here. Find the group most appropriate to our product, which would be vehicles and other transportation equipment, and then look for the detailed sector in the next drop-down list. Here we're going to select automobile manufacturing. For detailed information about a sector and what products and industries are included, you can scroll to the bottom of the page and view all details here in this gray box. This is important for products that may be included in a more ambiguous sector name. If you don't know what the best sector may be for the industry or product you're looking for, you can also quickly search for matching sectors instead by using a keyword. Using the search option, we type in auto, click on search, and a drop-down list has all appropriate sectors. And here we can find automobile manufacturing from here. The next step is to input the economic activity for the sector you selected. This value represents how much output is demanded from the sector in millions of dollars. Here we will assume that we are studying the impacts of producing 100 cars with production costs of $20,000 each. So we're going to set the demand to $2 million worth of automobiles. It's important to note that if you were analyzing a product that has a lower economic value, you may want to use a multiplier so that you have workable numbers in the results page. The reason for this is that the results displayed are presented with 3 significant figures, so smaller economic activities may return a non-zero value that is displayed as 0. We will give an example for this in the second segment. Now we need to select the impact category for study. The impact categories vary depending on the model year that you selected. We will start by selecting economic activity to show the purchases made by the automobile manufacturing sector across the economy to produce our $2 million worth of automobiles. We will look at the other impact categories in segment 2. Now that all inputs have been completed, you can run the model. Please watch the second segment of our screencast on how to interpret and organize the results.